the load event, which fires after your DOM and after all your images and external resources. After all of them have loaded, that event fires, and then your code can execute from there. Another event that is my personal favorite is DOM content loaded. Using for that event after your DOM is loaded, but just before everything else has actually loaded as well. So if you want to have code that runs that manipulates the DOM, that's a great time to basically hook into it. Because we're building apps that run on a device, having load or DOM content loaded isn't always a guarantee that your page is ready to react. You might need extra time for getting your keyboard working, or like external input from plugins like your camera or your accelerometer. They might take extra time. So we have a custom event called device ready that is in many ways the equivalent of load, but it is optimized for device-specific scenarios.
Cool. It's very useful. You will see device-ready event in many Cordova projects. That's the root event.
I think it's like the general guidance is, whatever you do, make sure you do whatever important things after the device-ready event has been fired. So, I'm sure. Sorry.
No, it's okay. We have two other events here, pause and resume.
Yep, I'm going to leave these as is. I have no need to modify them.
Okay.
So what I'm going to do though is let me quickly go ahead, and I could just write code manually, but I'm going to copy and paste some code just to save some time. And let's go ahead and paste this here. All right, so all I've really done is I've added a variable called changeColorButton, and I'm using the query selector function on document to get access to the element whose ID is changeColor. So nothing fancy going on here. And just like before, I'm adding an event listener for the click button, and for the click event. And so when that button is clicked, the setRandomColor event handler will essentially get called. And this event is basically calling, getting a hook into the body element, and it's setting the inline background color to a particular value. But just to make sure that everything still works fine, let's go with yellow. Let's just make sure that code up until this point works fine. So I'm going to go ahead and
let's try it.
I have no doubt that it will work, but you never know, right?
Oh yes.
Change color? Yeah, it works fine. So our code up until this point is fine. So what I really want to do though is not have a hard-coded color value. What I really want to show is a random color that changes the color of the background every time I click it. So for that, I have the getRandomColor function, and this function is pretty simple. All it does is it creates a random RGB color value, puts it into the right format, and just returns it in the way that your application would expect it. So all I'm going to do is just replace this with getRandomColor.
Go to the function, okay.
And that's all I'm going to do. So let's go ahead and hit play now. So, I'm going to click change color, and oh my gosh, it is not working, Eric. I mean,
there is a bug in your function.
There's a bug. Always when I'm demoing, stuff never just works, right? Okay. All right, so now let's try to figure out how to fix it. So there are many ways you can do this. You can write console.log, because it is a web. You can also write alert statements. There's no wrong way to diagnose and debug your code. As long as it works for you.
Personally, I love the breakpoint approach.
Absolutely, the breakpoints, you can't beat that. So let me actually just set a breakpoint just right here, just to figure out what values actually being returned by getRandomColor. So I set a breakpoint, and I hit F5. And now let's see what's going on. The application loads fine. I'm going to click on the button, and yes, the breakpoint gets hit. So now, body element, all this stuff is fine. getRandomColor is returning the function value. Let's figure out what getRandomColor actually returns. Let me go back to let's go to the immediate window, and let me just type in getRandomColor. And it returns a hex value, 7CE980. So that seems to be fine.
Yeah.
But can you tell me what's actually wrong with this, though? There's actually something subtle that's wrong with the value that is being returned.
The format of the value, perhaps?
Correct. The format of the value. It's almost as if we rehearsed this beforehand, Eric.
No.
No, this is actually true. This is completely live. We did not rehearse this beforehand, guys.
I just discovered the code at the same time as you guys.
The format is actually wrong. It is a hex. It is a value. It is hexadecimal, but there needs to be a pound sign in the front that needs to be recognized by your CSS. So the way to fix that is I'm going to go to my code, and where it says var hex color, where I'm returning the values, I'm just going to do some simple string concatenation and just do this. And hopefully with this, it'll all work fine. I'm actually not even going to set a breakpoint because I have such great faith that Eric's debugging ability have not led me astray. So I'm going to hit the button, change color.
Okay.
And
better.
The color changes, Eric.
Okay.
This is beautiful. This is all day, guys. We have about 23 minutes. I'm going to do this all day. All right. So that's a very quick overview of using Ripple for making some simple changes to your application. And then diagnosing and fixing issues by using some of the debugging stuff.
Yeah.
So now let's go back to our slides for a second.
Yeah.
And
Well, one question for you.
Yeah.
What happened behind the scenes?
what happens behind the scenes? We talk a lot about Cordova. We talk a lot about, it just
Yeah.
works on devices. But I think it's definitely helpful to take a step back and just look at how does your HTML, CSS, and JavaScript end up working in a device context? Like what exactly makes it, happen? So I created a few slides that help with this. So behind the scenes, you saw a little bit about the web view control
Yep.
that David was talking about.
Yes.
And what happens in a device is no different. You basically have a native application that has some functionality for displaying some HTML content. For iOS and Android, it is a web view container. And for Windows web applications, the HTML apps you run for Windows Store and Windows Phone, you have what's known as WWA host.
Yeah.
And all they do is they take your HTML, CSS, and JavaScript, give you some additional functionality, and have the ability to connect to the device capabilities despite using just JavaScript that runs in a security context that is optimized for the web app. And this is a very high-level diagram that talks about how an application code, and the one part that sticks out of your application and actually goes into your device is the plugin that that Eric talked about a little earlier, and we'll talk about a little more. That's basically the bridge between what you're writing and device capabilities your application requires. Because one thing you guys might not realize is that, if I'm running on a desktop and let's say I'm using the webcam, for example, right? I can just get user media, everything works just fine. When I'm viewing that exact same application on a mobile browser, not a mobile app, and a mobile browser, the security settings on a browser prevent some of this functionality from working as you'd expect. So you actually have to have this plug-in mechanism and a Cordova syntax for it to bypass and to work with the security model that all these devices.
Exactly. After the meal break, we will have a session focused on the difference between WebView and the WWA host in Windows.
Oh, that's fantastic.
Yeah.
Great.
Okay.
That will not steal the thunder from that session anymore then. Let's go to the next slide.
Okay, let's continue.
So we talked about in a very high level what exactly is happening. But we talked about a very low level on what's happening. Let's actually take a bird's eye view of what's going to happen. So when you're building an application for Cordova, there are two components that have pretty much been the mainstay, the dynamic duo of what Visual Studio has always been about. That is Visual Studio and MS Build. MS Build, you probably use it for building your applications from Visual Basic to C# to C++. It is a very flexible component that is used for all sorts of project management systems, from build project management systems. And what we're adding on top of it is we're saying we're going to extend MS Build by having some of its output go into the yellow box as VSMDA. That is the extension that you basically install. And that then massages the content a little bit and passes it on to Cordova. For Windows and Android, it goes straight to Cordova, which then does its work to provide the final packages, the APK for Android or the Apex files for Windows, and the equivalent packages for iOS, the .app packages. And for iOS, though, we have one extra step. On the slide, if you go to the right-hand side of it, you'll see that the VSMDA actually has another component, and these components run entirely on the OS X side of things.
That means I can develop for my macOS from Visual Studio without touching my Macintosh.
That is so. There will be some level of touching you will still have to do, though, Eric. And I'm going to demo that in a little bit.
Sure.
You have to install some components, and you also have to run a command line tool to actually have it running. So before I get there,
an agent.
Exactly.
But the principle is the fact is I stay in Visual Studio and deploy on my Mac, on my iPad or something like that without touching its code, right?
That is exactly correct. And let's say you have an environment where someone has already configured a build machine running on a Mac, for example. In that case, you don't have to do anything. You just basically hit F5 and just choose an iOS debug target, just like I chose a Ripple target, and you're golden.
Oh, I love it.
All right. So let's go to the next slide. Just there's one of the best things about what we released is our documentation. We have excellent documentation. So we go into great detail on how to set up your machine for building on a Mac. But just at a very high level, there's two things you need to do to build on the iOS. I'm going to demo this, which is why I'm giving you a quick overview of what to do. You need to install the VSMDA remote agent. It's a node package. Pretty simple. Run that. It just works. And then the next step is to basically run the agent so that it's always listening for communication from Visual Studio, in this case, to process a build.
Okay, and they are going to build in a certain directory for that.
Correct.
Okay.
So I'm going to go ahead and we're going to demo this now. It's going to be exciting, So all right. So I'm back on my machine. So this is a browser. This is basically Ripple showing an Android app, and pay attention to what the change color button looks like. Sharp corners and edges. And there's a reason why I'm calling this out, because you'll see there's a difference in how it renders on iOS.
Okay. Okay.
So
let's see that.
yeah, because Ripple is great, but if you want to do, if you want to ratchet up the fidelity when you're testing, emulator is a great mechanism, and so is ultimately, of course, testing on a device. And for iOS especially, I'm going to talk a little bit about how some of the things that look right on Windows might not look right when tested on iOS.
Okay.
So this is a great way to look into that. So I'm just going to first select an iOS platform. And once I've done that, we also give you the option for device, and Ripple makes an appearance here as well. So if I didn't want to actually do any kind of configuration, Ripple does an okay job approximating what's happening.
Okay.
It's not perfect, as you will see in a second, but I'm simulating an iPhone 5 using Ripple, and the functionality still works. If I had any code that used the WebKit prefix, for example, Ripple will respect that, and it will show it all just fine.
It's good.
So, but let's go to the part that that everyone is really excited for, building on the iOS. So I'm gonna test on, let's say, the iPad. Let's say iPhone simulator. So I haven't done any configuration yet, Eric. I'm just basically very naively selecting iPhone, and I'm gonna hit play. And this is not gonna work, and you'll see why. And okay, this is taking its time right now, but it's not going to work. Basically, we need to do it. There are two things you need to do.
Yeah,
let's go to Tools Options.
Yeah.
And by default, we have this actually disabled. So I'm going to go to Multi-Device Hybrid Apps, find the Remote Agent Configuration. So I've already set this up earlier. By default, set to false. You need to set this to true, and then pass in the machine that is going to be listening for these events. So, and as we were doing this, it appropriately failed, saying that error occurred according to the build server, timeout, because the build server isn't actually running. So let's go ahead and get this started. So I'm going to go back. I'm running Parallels right now. So I'm going to go back into the OS X side of things, and let me just bring up my terminal. So what I'm going to do is just start my VSMDA remote. This is the same command you saw earlier, and I'm putting the builds into a user's group of builds directory.
Okay.
And I'm going to hit Enter.
Okay, so the agent is listening for Visual Studio messages.
Exactly. It's basically now just running in the background, just polling and seeing what any updates there are. And if you remember from if I go back into Visual Studio, one of the options we need to specify is the IP address and the port. The port is 3000. You can see from the command line window itself.
Okay.
The host address is what I need to figure out next. And so for that, I'm actually going to open up another terminal window. And there are many ways of doing it. This is the way I tend to use it. I use ifconfig, and I wrote a small script that basically, ifconfig by itself is actually, let me show you what ifconfig does, just in case you are curious. Let me remove all of this. I hope it remembered my earlier settings. ifconfig is similar to like ipconfig in Windows. It gives you a lot of information about what you're currently doing. But let me just filter all this out and only give me the IP address I care about.
Okay.
So this is the one, 10.82.208.8. So I don't believe copy is currently enabled. So I'm going to quickly just note this down as somewhere. Let me go to one of the desktops here, and I'm just launching Notepad for those of you who can't see what I'm doing on this, oversized novelty screen. 10.82.208.8. All right. So now I need to make sure in Visual Studio that I enter the exact same value. Otherwise, my computer VS would have no idea how to connect to the build agent side of it. All right. 208.8. All right. So if everything works fine, I'm going to hit play. And it is currently uploading build request payload, attempt 1. It's always scary when a number comes up. Attempt number 2. And so behind the scenes, it's actually being sent to the OS X side of things.
Okay.
And now the build has succeeded, and you will see the iPhone simulator running, and now you get to see change color showing up here. And if I click on the button, you'll see that
it's working.
It works just fine. And the thing to note that, before I emphasize to pay attention to what the button looks like in Ripple the button was basically square shaped. And it had no translucency or transparency that you kind of see on an iOS simulator. There are subtle differences like this that really only shine when you're testing closer to the platform you're building on. So as great as Ripple is, the iOS simulator is a little bit better for testing iOS apps. Just Android emulator is better for testing some Android emulator apps. And then, of course, a device is one of the best ways of being able to test as well. So
pretty amazing. I have a question for you. Can I debug step by step from Visual Studio to my macOS here?
Currently it is not supported, but it is high on our list. So I would say very soon you should be able to set a breakpoint, step into your code and see all the iOS debugging functionality work just as it would for any other flavor that we actually support.
So right now I debug in Ripple. Test on my iPad or iPad simulator.
Correct. You can Yes, there are many other ways you can use some of the web tools that exist for iOS to connect to it. You can use the equivalent of process monitor. There are many complicated ways, but no, we have a much easier way that's hopefully will be out in the near future.
Okay.
Great.
Some more demo, perhaps?
Let's do some more demo. Yeah, why not?
Cool.
Why not? I mean, everything's working fine so far. So
I really enjoyed it.
We had to crash something.
I don't know you, but I really enjoyed it.
Yeah. Otherwise, this can't be a demo that we're giving as as part of Visual Studio. So all right. So basically, one of the things we talked about is plugins. We said plugins is really great, and we want to see what happens how to work on plugins. So I'm going to go ahead and open a new project. I created a project already. I'm going to give you a quick demo of what it looks like. And this project is a simple note-taking app. And now every demo needs to have a good to-do application. So I'm going to hit F5, and for this I'm going to stick back. I'm going to go back to the. Let's go back to Ripple. Let's do an Android device again. They're just so much fun to preview. I'm just going to hit play, and this will give you an idea of what the application looks like. And right now we're texting on a Nexus S device. And so basically, I had some pre-canned content that I was hoping wasn't going to show up here. Luckily, it's all fine. And it's basically a note-taking app. I can type in, finish this demo.
Okay.
For reals. And I'm going to hit enter. You'll see the item appearing here, and I can make changes. I can, delete an item once I've done it. The test totally works, so far. So I can delete it. We'll ignore that what I deleted was not the item that was actually removed. That's a minor demo bug. All right. But what I'm going to do though is I want to add a plugin. Right now it's a simple app. It's deleting items as I'm adding things to it. Wouldn't it be great to actually delete items if I were to actually shake the device? Like a lot of apps have the functionality where if you shake the app, either a help screen comes up or you get feedback.
You're right.
How about I'm so frustrated having no more tasks to do that I shake it and then it clears everything out. So let's go ahead and test that very easily.
Okay.
So in order to be able to do that, to be able to add some functionality for shaking the application, that requires access to device APIs. And those APIs are by default turned off in all these applications for security reasons.
Yeah, sure.
And as Eric mentioned earlier, the way you enable them is by using what's known as the Cordova plugin. Yeah. And these plugins can contain are basically a bridge between the JavaScript you write and the specific native functionality you expose. And there's basically a fork for Android, for iOS, for Windows, Vada, BlackBerry, all the platforms that that Apache Cordova supports. It is the plugins help mediate between making sure it works on the device itself.
So you add a tab about plugin here.
Right. So what I'm doing is, a lot of these are specified in the config.xml file. So you could edit the config.xml file manually. And this is basically the file that, you might have seen David, Eric show off. I can make these changes myself. Or, why write code when I can do some of these things, especially like custom markup, when I can use an editor for this. So I double click on config.html in Visual Studio, and you basically get our config, config editor, config designer. Here I can specify settings like my display name, the start page, the package ID, things like that. Any security settings, all these things are fine. Packaging, all these things are just, specific
in a graphical way
of specifying, often arcane, obtuse information. The thing I really want to talk about though is the plugins tab.
Oh.
Out of the box, we give you the ability to support all these various plugins, and us, for example, selecting the accelerometer, for example, isn't just a case of me checking a box and nothing happens. We actually acquire the plugin as part of build, and we do a lot of things behind the scenes to make it easier for you to basically just take advantage of the accelerometer, not have to worry about how to get them into your project. This goes back to one of the values that I think Visual Studio really provides.
Okay, so you have the core list of Cordova plugin, I think, here.
Yep.
And if I want more, I have to go by hand on the XML file, right?
Correct. Okay. So, we're running short on time, so I'm going to go ahead and open a finished version of my project. It actually contains all the code that I need. So it's currently in a zip file, actually. And we already have a folder there. Let me open temp, paste this in, and let's go ahead and open this. Okay. When it says this may take a few minutes, it's usually not lying. So I'm hoping it doesn't take, it does not take a few minutes.
Okay.
All right. So I'm going to go ahead and project is open. Let's test it in Ripple. And there's a reason why I'm testing in Ripple, actually. Let me actually take a look at what the accelerometer code looks like, just so you have an idea of, let me go back into,
Visual Studio.
This is the wrong app. let me go back into Visual Studio. Let me just open up init.js where the code lives for being able to access the accelerometer. It's right here, navigate.accelerometer.watch acceleration. And then the code basically just checks for simple acceleration where I'm checking the x, y, and z coordinates to make it work. And the nice thing about Ripple is that one of the functionality that I highlighted earlier is its ability to mimic a lot of device settings.
Yep.
And one of the things actually is the acceleration. Wow, that's a hard word. So you can see at the very bottom, there's I can click and drag the mouse to manipulate the device, great. But also a shake functionality, where if I click it, it basically moves the screen back and forth. Let me just zoom out a bit and see if you can see more of the screen. Perfect. I'm going to hit shake, and once I do that, you'll see the entire application shaking. And as a result, though, the item still went out of the screen. So Ripple is fantastic at being able to do that. And I also, for those of you who are watching, I actually have a physical screen, a device as well. And imagine if I were to plug this in and hit F5 and deploy the device, you'll see the exact Note app right here. And if I were to shake it wildly, you'll see the items delete themselves as well. So just imagine how awesome it would be if it worked. And I'll just pause as you get to just gaze in amazement at this working. All right. So with that, let's go ahead and start going to the wrap-up slides onto the resources, and let's see what else is there.
Some additional resources here. Of course, you can download the extension in hackims.cordova.
And one of the things we've done is that even if you're using Visual Studio to set up your machine, it takes time. It takes, sometimes it takes about 20 minutes, sometimes it takes about an hour or 2 hours, depending on your connection. And you also, because what we're building is still pre-release software, it still has some bugs in it, we're working through them. You may not want to have your main development machine, take up, pre-release content. So to help you evaluate them, we actually created both Azure VMs that you can connect to and run directly without having to have anything configured on your machine. And we also have like a massive, like VHD you can download from the Microsoft Download Center that gives you everything you need, both Windows and Visual Studio, evaluation versions of both, that give you everything out of the box to build a Cordova app.
The experience with the VM, the live VM, it's pretty amazing. We used that last week during the PhoneGap Day.
Correct.
We organized a workshop and we have several guys connected with a teeny connection, but everyone can work. It's pretty
exactly. I mean, the best part of the
for that. And the team for that.
Yeah, absolutely. And the best part of the VMs is that oftentimes you might need to have Hyper-V enabled, Hyper-V disabled. Depending on which emulators you want to try out. Your computer might not have, like, let's say SLAT for some of the CPU-based, emulators. That might be disabled. So you kind of don't have to worry too much about your hardware configuration. You can use a high-powered device or a very low-powered device and still be, very productive in, building these apps for real or for just evaluating things and seeing how it works. And then the last couple of things are, we do want to hear feedback from people, and if you do run into some issues, we posted our team is very active on Stack Overflow. We monitor all of the comments, and we try to respond to you very quickly. So just post on Stack Overflow, use the hashtag multi-device hybrid apps, and we will get to us. And if you tweet to us, VS Cordova Tools, you can email the product team directly at vscordovatools@microsoft.com, or if you want to email me, just feel free to email me as well, kurupasi@microsoft.com.
Okay. Very nice. Thank you a lot, Kirupa, about this presentation. I think we are really enjoyed the integration in Visual Studio. I really enjoyed it.
I enjoyed it as well, Eric.
Sure. So now we are going to have a meal pause, a long break, about 1 hour. See you later. So, bye.
Hi there, and welcome back. I hope you had a great meal, and also I hope you had a great experience with the previous sessions talking about Apache Cordova to be used for cross-platform development using web technologies. The actual module is about looking closer into what kind of issues you will face when bringing HTML5 and JavaScript code to build a cross-platform app. And here with me, I have Paul.
Hi, nice to meet everyone.
Paul, if you want to introduce yourself.
Yeah, I can do that. My name is Paul Gilday. I'm a program manager on the Web Frameworks team, or more known as on the WinJS team. I've spent a couple years here at Microsoft. I've worked on the UI platform from components in Windows 7, Windows 8, 8.1, and the past 2 years I've been on the WinJS team. I've been working with the team really hard to bring the library cross-platform as well as cross-device using Apache Cordova.
Awesome.
So yeah.
Great. So we were talking since this morning about the ways you can bring that web code onto applications. And there's one specific thing that is happening with Windows platforms in the way you can bring that web code. The one thing is actually that there's native support on the app platform for JavaScript and HTML5.
Right, that's
so
correct.
that comes with lots of goods, as in the integration into the development tools, the way you can do debugging, document inspection in Visual Studio. That gives you a level of control on that code, which is awesome.
Yes.
However, because there is an however, things are not always super nice in life, and so you will have to cope with something specific around the security model. So if you want to touch a little bit about that exactly, what is specific in the Windows app platform support for JavaScript to Windows that you don't have on other platforms when doing cross-platform with JavaScript?
Yeah, and so with great power comes great responsibility. And the interesting thing with our platform is that, especially in the context of Apache Cordova, Karupa on the previous talk talked about the different models that they use to actually implement Cordova under the hood. And so in the iOS and Android versions, you're essentially in a web view, and then you marshal calls back and forth out of that web view to the native platform. But on the Windows platform, we support HTML natively, meaning that you have local access to the APIs, and so we don't have to do that marshalling call. And so the JavaScript that you're running essentially has full access to WinRT underneath. And so, especially in some of the ways of the web, a lot of those responsibilities have been taken care of you by the sandbox that you have in the browser. So you can't, essentially do bad things to an end user. And so, on the Windows platform, you have a lot more control, but now you have to be a little more conscious of what scripts that you're using, what you're including, and what those scripts do.
Okay. So there's more responsibility in the developer's hands. However, there's also some control that the Visual Studio tools actually will add.
Yes.
And you're going to show us there's a specific error you might run into when you bring your JavaScript code, and you'll show us how that works. Just bringing a library from out there, dropping that into a Windows application, and boom, when you start it, you get that big message.
Yeah, and so I'll just switch over to the slides here, and if you have any familiarity with building a Windows 8 application using third-party libraries, you might actually run into this issue. And so we can actually switch over to Visual Studio to see this in action.
While you're switching, I'm wondering also, so why would we do that to developers? Like, why actually would we not just expose the same, functionalities and APIs as in a web context? So the reason for doing that actually are beyond they're about security for the final user, right?
Yes, I guess there's two things. When we were thinking about the Cordova implementation, we wanted to have as fast performance as possible. A lot of in the debate between HTML5 versus native application programming, it's all about performance and that native feel. And so we could have taken a route where we web viewed the content, but we would still have to marshal back and forth. And so since we don't do that, we give you that direct access to that. And so we feel that was the right decision moving forward. But yes, we're going to have to use the developer. We'll have to understand some of those implications that we've made.
Got it. So it's really about understanding that you're running in a different context.
Right, exactly. Yeah.
Awesome. Show us actually the kind of things that you're not allowed to do, or that are flagged as unsafe in your code.
Sure, yeah. So in this example here, I'm just including a common JavaScript library that most of you probably use. This is AngularJS. And so I'm just going to run this in the context of a Windows application. And so I've just included it. I think this is version 1.3.
So you just created a Windows Store app using JavaScript support.
Yep.
And that's what you get. For those who are not familiar with Windows Store app, you can see that you have a CSS folder, JavaScript folder.
Yep.
So that's very common to any other web application. You see not index.html, but default.html.
Sure.
But that's exactly the same thing as if that thing was running on a server as an app, right?
Right, yeah, exactly.
A web app.
Exactly.
Good.
Yeah. So hopefully if we click go here, we'll get our breakpoint and our error.
Nice.
And so this is good. Well, yeah, and it's bad, right? So we're going to break, and this is where it becomes problematic for the developer. Is that so we're breaking actually inside of AngularJS's code, and if I'm a developer using that third-party library, I might not be fluent in all of the programming models that is built into WinJS or built into AngularJS, and so that could be a really tough blocker for me.
Yep. And if you start venturing into making changes to the framework for your own use,
Oh, yeah.
actually, next time you get an update to the framework,
Right.
you have to go through these changes again. So it's definitely not viable. I would say as a solution, go tinker yourself with the code to adapt it to Windows platform.
Yes, yeah, you will definitely incur a big maintenance cost for your application. And so to answer the question that you were talking about before is what type of interactions that are considered blockers in the security model essentially is around DOM manipulation and more specifically around script injection. So this is your inner HTMLs, your insert adjacent HTMLs where the platform might not know where that code